In this video, we are going to learn about normal and standard normal distribution along with some questions for finding the area or probability for the given questions. Now, normal distribution has a probability distribution function which is given by fx equals to 1 over root of 2 pi times sigma e to the power 1 by 2 x minus mu by sigma whole square. Normal distribution gets converted into standard normal distribution when the value of mean is 0 and standard deviation equals to 1. And the function gets changed to fx equals to 1 over 2 pi e to the power minus x square by 2. When we are finding the area for the given normal distribution curve, actually we are calculating the probability for the given distribution. And it is important for us to know that the area within the standard normal distribution curve is equal to 1, or the sum of all the probabilities given within the standard normal distribution is equal to 1. Any normal distribution can be converted into standard normal, and standard normal can be converted into normal distribution using these rules. In this video, we are going to learn about these three types of situations, these three scenarios where the z-scores are given and we are calculating the areas for the given situation. Let's begin with some examples. Now I'm going to discuss two types of method or two methods to find the area for the given distribution using the table and using the online calculator. So first method is using the table. In this question, we have been given or we have been asked to find the probability for all z smaller than 1.04. Now 1.04 is lying over here. This is somewhere here we are going to have 1.04. Our aim is to find area or the probability for this region. I'm calculating or I'm shading the left region because the standard normal distribution table gives us probabilities only for the left area. We can also make out from the table. This is a standard normal table, and in this standard normal table we have two pages. One is for the negative z-scores and the next page is for positive z-scores. We already know that this standard normal distribution has the z-scores given equally divided into two regions. This is where we have the negative values of z-scores and this is the positive values of z-score. When we have the area given only for the left part, all the values of the probabilities for the negative z-scores are from 0 till 0.5, between 0 till 0.5. And on the next page, when we will have where we have the positive z-scores, all the areas are lying from here till further. So from 0.5 till 1, all the probabilities are included here. Now let's learn how to read this table. To read this table, we have the z-scores given here. These are 1 decimal places, and this row indicates the second decimal place. Same is the allocation on the positive z-score also. Going back to the question, we have been asked what is the area or the probability for all z which are smaller than 1.04. The z-score 1.04 is a positive value, so I'm going to go to positive page. I'm going to look for 1.0. This line represents 1.0. This line represents 1.0, and then I'm going to go to 0, 1.0, and then 4. This is the column of 4. So 1.0, 4, 0.8508. 0.058508 is the probability for this. So the probability is 0.8508. This is the area for the curve or the standard normal distribution which is less than 1.04. Similarly, if I want to check this value on the calculator, so I'm going to calculate it for below. Mean is 0, standard normal distribution 1. Below, I'm going to calculate it for 1.04, 1.04 and calculate 0.8508. So this is the shaded region, which is similar to the one which we have done here. This is from the table and this is the value obtained from the calculator. So either way, we can obtain the solution for this. Let's go back to second question. Probability of all z greater than 1.34. Let us solve it using the table first. Now 1.34 is going to lie somewhere between 1 and 2. 1.34 is here between 1 and 2, 1.34. Now they're asking the probability of all z which are greater than 1.34. So these are the values of all z which are greater than 1.34. Our aim is to find this area. Now we should notice that they are asking for the area for the right tail, whereas the probability table gives us value only for the left tail. Because of symmetric distribution, we know that corresponding to 1.34, there's going to be minus 1.34 also, minus 1.34 also. Area for this curve is going to be same as the area for the other part because of the symmetry. And so the same question can also be written as probability of z. I'm changing this right tail into left tail, changing the sign of this z score 1.34 into minus 1.34. So the question gets converted to a left tail question, and easily we can use the table to find the probability now. For minus 1.34, I'm going to go to negative page. On the negative page, minus 1.3 is this line, minus 1.3 and 4, 0.0901. This is the value for the probability. So the answer for this is equal to 0.0901. And same question can also be solved by another way also. Same situation. If I say that for 1.34, I need to calculate this area. This is going to be 1 minus this left tail area because the total is 1. So 1 minus probability of z less than 1.34. If I calculate the area for this, I'm going to get the same result as for this one. Now let's verify the answer with the calculator. Probability of area above, I have the value given as 1.34. I don't want below, so I'm going to remove that and recalculate. Now 0.0901, this is the answer for that. Third scenario, when we need to find the probability between two z-scores. Now we can see from the question that one of the value given is 1.05. So one of the value is this, which is 1.05. And the second value 1.16, which is very close to 1. So somewhere over here, 1.16. This is the area which we need to calculate. To find this area, the method for calculating it as we find the probability for all z, which is smaller than 1.16. So I'm going to calculate this whole region first, minus I'm going to remove the probability for 1.05 from the calculator and from the table. Both ways, alternatively, we can calculate the probability. Now for 1.16, going to the positive page, 1.16. 1.1 is this line, 1.1, we want 1.16. So this is 5, this is 6. 1.16 is 0.8770. So the bigger probability corresponding to this is 0.8770 minus probability for 1.05. On the positive page, I'm going to find it for 1.05. Let us erase these values first so that the table is clear. I'm going to find it for 1.05 now. 1.0 is this line. I'm going to go to 5, which is this value 0.8531. Going back to question, the value for probability for z less than 1.05 is 0.8531, and when we solve it, we get the value as 0.0239. Let us verify the same answer with the calculator. We have the value in between 1.16 and 1.05. Recalculate. I should write the lower value first actually, 1.05, and then the upper value, which is 1.16. Recalculate. 0.0238. Maybe I made some calculation mistake, that's why I have slight difference in the value. So, or maybe this is the approximated value, that's why you see slight variation. So this is how we calculate the probabilities for the z-scores lying between the two values and the value above z and below z.